Alright, so hello, annyeong everyone. So dalam video ni, Madam akan ajar 4.2 Determinant of Matrices. Okay, so dia ada tiga mini subtopik bawah 4.2 ni lah. So first kita akan pergi dekat page yang this one. Okay, so 4.2.2 Determinant of a Matrix. So determinant of a matrix dalam syllabus awak akan belajar macam mana nak cari two types of matrices punya determinant. So the first one is for 2 by 2 matrices. And then the second one is for 3 by 3 matrices. So before you can know how to find this 3 by 3 matrices, awak kena tahu dulu macam mana nak cari 2 by 2 matrices. Okay, so let's say kita ada satu matrix dalam 2 by 2 and then kita ada A, B, C, D. Okay, so determinant, the symbol for determinant adalah this modulus. Okay, so nampak je modulus maksudnya determinant of matrix. Okay, so apa yang kita akan pakai, the formula is AD minus BC. Simple saja. So kita akan darabkan A dengan D. This A times with D. Okay, this one goes first. And then, kita darabkan pula B dengan C. Lepas tu, kita tolak je dekat tengah tu. Okay, so let's do an example. Few examples. So, example 8, kita nak cari modulus of A over here. So, this is our matrix A. Right, so the formula is AD minus BC. So, meaning that, kita akan darabkan the leading diagonal first. So, 2 times 8. And then, it's minus in the middle, 5 times 3. Okay, so 2 times 8 is 16 and then minus 15. So your determinant is equal to 1. Okay, next example. So determinant for matrix B. So we have over here again A times D. So leading diagonal first, 3 times 2 and then minus with 2 times 5. So we have 6 minus 10 which is equal to negative. Settle. Right, then we go back to the first one, 4.2.1. Okay, so you are going to learn how to find minors and cofactors of matrix. So this is important in order for you to find the determinant of a 3 by 3 matrix. Okay, so what does it mean by a minor? So minor is actually the determinant of a matrix that we will obtain by deleting the ith row and jth column. So you will delete the row and the respective column from some larger square matrix. Okay, so let's see straight away to the example. Example 5. So it's stated over here, we need to find all the minors of the elements in the first row of matrix. First row. So first row means that this row. Okay, so we have 3, negative 1, and 0 at the element. Okay, so how do we obtain a minor is we need to delete. We are going to delete the row and respective column. Okay, so first, we focus for the first element over here, which is 3. Right, so what I will do is I will write M. M stands for minor, small letter M, so M-I-G. Okay, so kita gantikan substitute I dengan J tu dekat elemen kita. So elemen kita duduk dekat row 1, column 1, like that. So maksudnya M11 lah, like that. Okay, so we just delete this row 1 and this column 1. Just delete it like that. Okay, so we have now letak je simbol modulus ni dekat sini. And then whatever number that is left inside. So we have 1, negative 3, 0, and 4. So you put it inside this modulus. 1, negative 3, 0, and 4. Okay, so now next step is we are just going to calculate it by using the AD minus BC. So we have 1 times 4 is 4. And then minus with negative 3 times 0. So we have just 4. Okay, settle. So now moving on. So let me erase this one. Okay, so now we want to find for this element, negative 1. Okay, so negative 1 is located at the first row, second column. Okay, so we are going to delete this first row and this second column. Okay, so we will write M12 equal to, so the element that is left is 2, negative 3, negative 2, and 4. So do a modulus. And then just calculate the determinant of AD minus BC. So 2 times 4 minus negative 3 times negative 2. So you have 8 minus 6 is equal to 2. Okay, and then moving on to the last one. So the last element that we have is we want to find for this 0. Okay, so we just delete this row and this column, and then this is located at the first row, third column. So we write M13. This is equal to modulus of 2, 1, negative 2, 0. So this is going to be equal to 2 times 0 minus with 1 times negative 2. Okay, so 2 times 0 is 0, and then we have 2. Okay, so this is our answer for the minor for all the elements in the first row over here. Right, moving on. Next one is cofactors. Okay, so cofactor. What is cofactor? Cofactor is labeled as Cij. Okay, so cofactor of the element Aij is, so look at this formula carefully. So we have over here is negative 1, and then the power we have is I plus j. And then this m means that we just need to multiply it with the minor. Let's say I have a 3 by 3 matrices with elements A, B, C, D, E, F, G, H, and I. Like this. Okay, and then if let's say I want to find the cofactor of this one. Okay, so that one is located at the second row, first column. So I will write it as C21. Okay, so this is equal to, following the formula, we have negative 1 power of I plus j. So our I is 2, our j is 1. Okay, and then our minor. So minor is Mij, means that M2, 1. Okay, so and then that is if we want to find the cofactor that is located at element D. So what if we want to find it at over here? Okay, so over here means that it's C3, 3. So we have negative 1 to the power of 3 plus 3, and then you just need to multiply with the minor of 3, 3. Okay, so you will see a pattern over here. So this one, if you notice, this power will become 3, means that it is an odd number. So if we have an odd number will produce a negative sign. Okay, and then for this one over here, we have an even number, which is 6. So 6 will produce a positive sign. Okay, so for a 3 by 3 matrix, the sign of cofactors are actually alternate. So the first one is going to be positive, negative, positive, then negative, positive, negative, then positive, negative, positive. Okay, so now let's do an example. So find all cofactors of the elements in the first row of matrix. So again, we are using the same matrix as the minor example. So we want to focus at this row, the first row. Okay, so we will write the first one as C11 because the element over here is 1, 1, and then 1, 2, lastly is 1, 3. Okay, so for C11, we have negative 1 to the power of 1, 1, and then our minor is M11. Okay, so negative 1, sorry, this is 1 plus 1. Okay, so negative 1 power 2, we will have positive, and then M11 is the one that we have up here, so it's 4. Right, so your answer is just 4. Okay, and then the next one we have for C12. So C12 is negative 1 to the power of 1 plus 2 with minor of 1, 2. And then we have negative 1 to the power of 3, which will become negative. And then minor of 1, 2, we already found it, it is 2. Okay, so this is our answer. And then for the last one is C13. So for C13, we have negative 1 to the power of 1 plus 3, and then M13. So this is equal to negative 1 to the power of 4. So we have positive. And then our minor at 13 is 2. So our answer is just 2. Okay, so actually minor and cofactor is related. So it's just the matter of the plus minus sign. Okay, so if it is located at the first row means that the sign is going to be positive, negative, positive over here. Okay, just like what we have calculated, it's positive first, and then we have negative, and lastly we have positive. Okay, so let's see if we want to find the cofactor at the Third row is over here. Okay, third row is over here, means that the sign will be positive, minor, negative, minor, positive, minor, just like that. Okay, so now moving on. So example 7, given that A, right, so we need to find all these things. So let's settle it first one by one. So A first. So find A11. A means element. So element that is located in the first row, first column. This one. So the answer for this one is 1. And then we need to find M11. So M11 means that you delete the first row and the first column. So we will have modulus 6, 1, 4, negative 7. Like that. Then calculate the determinant. So 6 times negative 7 is negative 42. And then minus with 4, you will have negative 46. Okay, and now remember, for the element that is located in the first row, first column, the sign will be, I will write it for this column. So the sign will be positive, negative, positive. So means that for the cofactor part, the sign is gonna stay just the same, which is positive. So it is equal to 46. Okay, next one. So for the next one, it's element to 1. A to 1 means that row to column 1, the answer is 4. So for the minor, you just delete the row and the respective column. So we have modulus of 5, negative 2, 4, negative 7. Okay, and then multiply the AD minus BC, so negative 35 minus, it's always minus in the middle, and then negative 2 times 4 is negative 8. So you have negative 35 plus 8 is negative 27. Okay, settle. And then for the cofactor is going to be negative sign over here. So we put negative over here, and then the minor that we have is negative 27. So our answer is just 27. And then lastly, for the final element, so it's 3, row 3, column 1. The answer is 3. Then delete the row and the column. So we have modulus of 5, negative 2, 6, 1. And then you have 5 times 1 is 5, minus negative 2 times 6 is negative 12. So we have 17. Right? So for the C31 is positive sign. So our answer is just 70. Okay. So now let's continue in finding determinant of a 3 by 3 matrices. Okay, so determinant of a 3 by 3 matrices can be evaluated as the sum of the products of elements of any row or column with their respective cofactors. If let's say from this formula, I want to use the first row. First row means that I want to choose this row. Okay, then my determinant will be AC1 times its cofactor of element A11, and then A12 times the cofactor of element 12, and then element of 13 times the cofactor of element A13, just like that. Okay, so you can choose any row or any column that you want. So the tips is that we will choose any row or column that has most 0. Right, so let's see example 9. So find the determinant. So for this one, we see that 0 is located over here. Let's say I want to use the second row first. Okay, let's try using the second row. So what we will do is write the symbol for cofactor. So for the second row, the symbol started with negative, then positive, and then negative. Okay, so we do equal over here, and then we put negative in front. Why negative? Because it's negative over here. And then we write the element. Our element is negative 3. This negative 3. Okay, and then the next step is we are going to find the cofactor. So the cofactor is same as the minor. So we just need to delete this and this one. Okay, so modulus of negative 5, 1, 5, negative 4. Okay, settle. And then moving on to the next element. So next element is with positive sign. So it's gonna be plus over here. And then we have element 0. So write 0 in front. And then delete the row and the column of 0. So this row with this column. So the element that are left for us, 2, 1, 2, negative 4. Okay, and then lastly, alright, so lastly we have minus. Our symbol is minus, and then our element is 1. And then we delete this row and this column. So we are left with 2, negative 5, 2, 5. Okay, so now let's simplify. So the first one, negative times negative 3, we have 3. And then for the determinant part, so negative 5 times negative 4, we have 20. Then minus with 5. And then for the 0 part, you just write it as plus 0. Easy. Then final part, we have negative 1, means that it's minus. So minus with, so you have 10. And then minus with negative 10. So let's simplify our answer. So we have 3 times 20 minus 5 is 15. And then minus with 10 minus negative 10 is 20. So we have 30 minus 20, and our answer is 10. So the determinant of this matrix is equal to 10. Okay, so this is when we use the second row. Okay, second row. Right, then I want you to try finding it by using the second column. Okay, so do the exact same step. So if you have any problem, you can ask me. Okay, so moving on to the last part is 4.2.3 properties of determinant. So properties of determinant ada 7. Okay, so ada 7 semua sekali. So the first property adalah there is a correction a little bit dekat sini. Madam tersalah tulis. This is not T. Wait, let me just cancel it. So this is not T, everyone. So this one is supposed to be modulus of A, determinant of A. Right, so the first property stated over here is if you have A transpose, okay, so the determinant of A transpose is equal to the determinant of A. Alright, so let's see example over here. So we have matrix A. This is our matrix A. And then the determinant of matrix A is equal to 90. So we want to find this one. You need to delete this one as well. Sorry guys, banyak betul dia punya typo. Okay, so lagi sekali. So this one, kita ada determinant of A. So determinant of A kita is equal to 90 over here. Okay, and then disuruh kita cari this matrix pula. Okay, so kalau perasan matrix ni sebenarnya adalah transpose of matrix A. So this column jadi this row. Ataupun terbalik, this row jadi column pertama. And then second row jadi column yang kedua. Then row yang ketiga dia jadi column yang ketiga. Okay, so for the matrix maksudnya for the determinant of the matrix, so awak akan terus dapat dekat sini nilai dia sama je dengan matrix asal dia, which is 90. Alright, and then second property, so if we have two matrices multiplied together, so the determinant of these matrices is equal to the determinant of A times determinant of B. Okay, so let's say over here I have determinant of A equal to 90, and then determinant of B is equal to 12. Okay, so dia suruh kita cari find determinant of AB. So senang sahaja. So kita punya formula adalah kita tahu determinant of A times B is equal to determinant A times determinant B. So means that 90 times with 12. So what we have over here is 1080. Okay, that's it. And then property number 3, so if A is an n by n matrix, so it's a square matrix, and then K is a scalar, it's a constant. So the determinant of K times with matrix A is equal to K to the power of n determinant of A. Okay, so let's see example over here. So kalau tengok dekat kita punya yang ini, dia macam tak faham sangat kan. Okay, so tengok dulu example. So kita ada determinant A. This is our determinant lah. Okay, awak nampak ada modulus ni, maksudnya determinant lah. So dia sama dengan 90. Okay, so saya buat dulu example C. Sebab example C ni sangat hampir dengan yang ni. Right, so perhatikan betul-betul perubahan pada setiap row dan kolom kita. So, dekat row pertama, kalau awak perasan, kita punya 2 jadi 6, and then kita punya 3 jadi 9. So, maksudnya diorang ni darab dengan 3. So, diorang darab dengan 3. Macam tu. Okay, so and then the second row kita, so our second row is 27, 9, and 18. So, if compare with the original, it's also being multiplied with 3. Then, for the last one, 3A, 15, and 12. So, this one pun sama, kita darabkan dengan 3. Okay, so macam mana cara kita nak cari determinant dia? So, determinant dia akan jadi 3 to the power of 3 and then times with 90. Okay, so awak akan dapat dekat sini. We have over here is 27 times 90. 2430. So, this is our determinant. Okay, so basically every element dekat dalam matrix ni, every element dalam matrix A ni darab dengan 3. So, bila darab semua dengan 3, that's why dia jadi 3 power of 3 dekat sini. Okay, so saya pindah dekat bahagian yang ini, example yang pertama. So, cari perbezaan yang ada antara A dengan matrix asal, antara this one dengan this one. Okay, so the difference, satu benda sahaja. So, you notice that your first column over here, okay, so your first column over here with this first column over here, so it's been multiplied with 2. Okay, so kita darabkan this first column dengan 2. So, kalau darab dengan 2 means that kita punya determinant, awak kena factorize the 2 out first, like that. And then you will write back the 403. Oops, sorry, it's not 403. It's the original one. So it's 203 936 E 5 4. Okay, so this is equal to 2 times 90, which is equal to 180. Okay, and then what about example B? So for example B, if you notice, so our second column over here, with this second column, so we multiply this one with 2, multiply with 2, and then our third row, oh sorry, it's the first row. So the first row is multiplied with 2 as well. So we multiply this one with 2, right? So how to find the determinant? So let's just do it simply like this. Okay, so awak bawa keluar je. First 2 we put over here, and then we have the second 2 we put it over here, and then lastly you just times with 90, which is equal to 90 times 4, 360. Okay, settle. Okay, so contohlah kalau kita punya soalan ni sekarang dia lain sikit. So let's say kita punya row pertama darabkan dengan 5, contoh. And then row kedua, dia nak tukar pula. Dia darab dengan 2. Times 2, times 5. And then yang last kali ni, let's say dia darab dengan 3. Contoh. Okay, so our determinant kita dia akan jadi 5 times 3. Times 2 dulu. 5 times 2 times 3 and times with 90. Contoh. Okay, so awak akan darab semua skala yang didarabkan dengan awak punya row ataupun kolom awak. So, didarab dengan 5. And then darabkan dengan 2. So, darab dengan 3. Last kali, darab dengan determinant kita. Contoh. Okay. So, property number 4. So, the value of the determinant changes sign when 2 rows or columns are interchanged. Diorang punya kedudukan ni berubah. So, let's see. So, we have determinant of A, matrix A. So, perhatikan perbezaan dia. So, saya perasan yang this column, this row dah tukar dekat sini. And then, this row tukar dekat sini. So, yang kekal hanyalah yang ini sahaja. Okay, so kita nampak dekat sini 2 rows being interchanged. So, how do we find the determinant? Sama sahaja dengan negative 90. Just put negative dekat depan. Okay, and then next one. So, if every element in a row or column is 0, then determinant of A is equal to 0. So, we see over here, the third column that we have over here is all 0. So, determinant is going to be 0 straight away. Okay, next one. So, if any two rows or columns are identical means sama, sebiji, okay, then the determinant is also going to be equal to 0. Okay, so then we have over here the first row is equal to the third row. So, it's identical, sama je elemen dia tu. 2, 3, 4, sini pun 2, 3, 4. So, determinant dia straight away terus dapat 0 macam tu. Okay, last property. So, if matrix A is an upper triangular, lower triangular or diagonal matrix, and then the determinant of A kita boleh dapat by multiplying the elements on the leading diagonal. So, just need to multiply the elements on the leading diagonal. Okay, so tengok dekat sini, awak ada 0 over here. Okay, so this is a lower triangular matrix. Lower triangular matrix. Okay, so what we need to do is to just multiply the leading diagonal to find the determinant. So we have equal to 3 times -5 times -2. Okay, so we have 30. That's it. Okay, so that's all from this video. Nanti madam akan beritahu soalan yang awak kena try. So if you have any question, you can always reach out to me. Jangan senyap kalau tak faham, okay? Okay, so bye-bye.